Today, we're unpacking a massive, really fundamental shift in how developers are actually building AI agents. We're moving away from the endless frustration of fighting monolithic AI frameworks and stepping into this entirely new era, composing modular, independent agent harnesses. Seriously, if you've ever felt completely boxed in by the tools you're using to build agents, you are going to love this. Mike Piccolo, the founder and CEO of III, perfectly captures this universal developer pain point. He says, if something inside it doesn't fit, you fork it, fight it, or work around it. I mean, we've all been there, right? You grab an off-the-shelf framework, it's amazing for the first week, but the literal second your agent needs a custom tweak, you just hit a brick wall. Okay, let's dive into this. Here is our roadmap. 1. The monolithic framework trap. 2. Dissecting the agent harness. 3. The modular worker solution. 4. Painless debugging with open telemetry. 5. Architecture as a slider. And 6. Compose your own system. Let's jump right in.
Starting off with Section 1, the monolithic framework trap.
To truly understand the trap, we kind of need to look at what we're actually dealing with. An agent harness is basically your engine room. It's the framework you adopt to provide tools, memory, and orchestration for an AI agent. But traditionally, development teams don't build this themselves. They just pull it off the shelf. They import it as a single, indivisible block. Think about your standard LangChain or OpenAI SDK setups. You're getting the whole shebang as one giant, rigid bundle. And this sets up a huge false dichotomy in AI development. On one hand, you have monolithic frameworks, which force a single decision bundle. If you want to replace just one piece, like, say, the policy engine, you usually end up having to rip out and replace the entire system. Then, on the other hand, custom-built historically meant that the moment the framework's default setup failed you, you had to abandon ship and rewrite everything entirely from zero. It's totally a lose-lose scenario. So, what's actually going on under the hood that causes these monoliths to buckle in production? Which brings us to Section 2, dissecting the agent harness. A harness isn't just doing one simple thing. It's doing an absolutely staggering amount of heavy lifting. Every single turn, it has to resolve provider credentials, drive a really complex per-turn state machine, dynamically assemble the system prompt, load skill bodies and schemas, stream tokens back to the client, check tool calls against your internal security policies, and even route calls for human approval. Oh, and it keeps going. The harness also has to track LLM spend against your budgets, run pre- and post-call hooks, persist branching session history, compact those session context windows when they inevitably fill up, emit event streams for your UI, and somehow carry open telemetry traces across all these different steps. Bundling these 13 completely independent concerns into one massive monolith, yeah, that is exactly why you hit friction later on.
So, the million-dollar question here. Why does bundling these 13 distinct jobs lead to inevitable system rewrites? Well, it's pretty simple. A year into your project, you're going to realize the specific approval gate or budget tracker that your framework shipped with just isn't cutting it for your enterprise needs. And when they're all super glued together, fixing that one thing breaks everything else. We desperately need a radical architectural shift.
And that brings us to the fix, Section 3, the modular worker solution. Let's contrast these two approaches. The monolith keeps those 13 jobs bundled into one rigid codebase, shipping just a single version of everything. Modular workers completely flip the script. They separate those 13 jobs into distinct processes running on a shared engine. Every single one is versioned independently, every single one is instantly swappable. By perfectly separating these concerns, you're literally preventing future system rewrites. Now, you might be thinking, okay, but how do these separate workers actually talk to each other without creating an absolute integration nightmare? The secret is it.trigger. It's a single primitive and trigger bus that uses a shared WebSocket protocol. Every single independent worker uses this exact same primitive to connect and communicate across the engine. It just strips out all that custom integration logic. Let's look at a concrete example from the III stack. You've got the turn orchestrator handling the durable state machine. But notice that approval gate is totally separate, just waiting on the bus to route human-in-the-loop decisions. The LM budget worker independently manages spend caps. The auth credentials worker sits quietly on its own as a vault. Every worker just does its one specific job, and it does it exceptionally well. But of course, separate workers sound amazing until something inevitably breaks. So how do we track what's going on? Section 4, painless debugging with open telemetry. Being able to carry one continuous open telemetry trace across every single step is without a doubt the missing piece in building reliable agents. In most complex AI setups, Distributed tracing is like the very first casualty. You end up staring at this massive black box with zero idea why an agent hallucinated or why a specific tool call failed. But the way this modular setup handles it is honestly brilliant. Step 1. The run starts and automatically seeds the session and message IDs as open telemetry baggage. Step 2. Thanks to a really smart proxy wrapper, this baggage propagates automatically to every single nested trigger call across all your independent workers. And step 3. Your spans are grouped perfectly by session, message, and function right in your UI. The trace aggregation is completely automatic. You don't write a single line of code inside your workers to track it. And this perfectly sets up one of the coolest conceptual models for scaling your architecture. Section 5. Architecture as a slider. This concept completely ends the whole thin versus thick harness debate. A thin harness might just be your orchestrator, a provider, and your credentials, which is perfect for when you're just trusting the model on some internal experiments. A thick harness, on the other hand, runs all 13 workers, plus complex policies and Slack approvals for heavily audited customer workflows. Under a monolithic model, these are entirely different beasts, but here, they exist on the exact same spectrum. And that leads to this massive aha moment. Moving from a thin harness to a thick harness is quite literally just a config file change. It's not a rewrite. Think of it like a volume slider. You just move the slider up by adding workers to your YAML config. Scaling up your complexity no longer means throwing your entire codebase in the trash. So let's look at what building your own actually feels like for a developer in the trenches. Section 6. Compose your own system. The mechanics of replacing any given layer are incredibly straightforward. Let's say you want to swap out a static model catalog for a highly dynamic live API worker. First, you just pick the layer. Next, you write a new worker that registers the exact same functions on the bus. Then, you simply run the command ii worker add. Instantly, the rest of the stack starts using your new worker. The orchestrator doesn't even blink. It has no idea you swapped it out. You never have to touch the core logic. Which brings us full circle to the core thesis of this whole explainer. As Mike Piccola says, you don't adopt a harness, you compose it. You install the base workers you want, you write the specific custom ones you need for your unique business logic, and you end up with a system shaped exactly like your needs. The harness is the composition itself. So I'll leave you with this thought. Are you ready to stop fighting your framework and start composing the perfect agent harness? Imagine an architecture where you literally never have to rewrite from scratch again just because one tiny piece didn't sit. Dive into modular workers and completely rethink how you scale your AI architectures. Thanks for joining me on this explainer, and keep building.